Sorry, I think I cut myself off. I'm trying to illustrate now what's on the next slide, and let me show you that. This is, again, how do we solve these kinds of equations and inequalities? So in other words, let's say W was an algebraic expression in X. It could be X alone, but it doesn't have to be. And what I was trying to show you is, I was trying to illustrate why these methods work. You know, why do we solve this equation this way? Right? This is saying to solve this equation, we solve these two corresponding equations. To solve this inequality, we solve this corresponding compound inequality. Same thing over here. I was just trying to illustrate why that's the case. I mean, was I successful? I think I was, so I hope so. All right. So basically from here, right, to solve this equation, you have to solve these two corresponding equations. For this inequality and this one, you have to solve these two inequalities. Excuse me, for this inequality, you have to solve this compound inequality. For this one, you have to solve this compound inequality. All right, that's good. All right, let's do some examples. I did email a worksheet, so after I do an example or two, I'll have everyone work on the worksheet. All right. So let's say we have this to work on. Let's say we want to solve this equation, right? Okay. So what do we do? Well, what is this slide saying? We have to solve this equation equal to b and negative b and equal to negative b. So from here, we have to solve this equation, and we have to solve this equation as well. Okay, that's what we have to do. We have two equations to solve. Okay, so let's do that. The first one, 4x plus 9 is 3, right? And what do? We subtract 9 from each side, right? Like so. We get 4x is negative 6. Okay, you know, again, when you solve an equation like this, you want x to be all alone. So we get 4x is negative 6. From here, we get 4x is negative 6, but we don't want 4x, we want x. So we divide by 4. And doing so, we get x equals negative 3 over 2. So that's one solution, right? Again, this is one equation we solve. We want to get x all alone. So we subtract 9 from both sides, right? To get the 9 out of there, 4x equals negative 6. We have 4x equals negative 6, right? And then to get the 4 out of there, we divide. And that's what we get. Good, good. Okay, so we get negative 3/2. Now, is that the only solution? Is that the only solution? No, we have to consider this equation. That's what I'm doing. So what do? Subtract 9, right? You know, it's really the same steps, actually. But of course, the answer is going to be different. Subtract 9 from both sides, right? Because we want x to be all alone. We get 4x now is negative 12, right? Then we get 4x equals negative 12, right? I just brought the 4x over. Just like in the previous slide, we want x to be all alone. So what do? We divide by 4. And remember, with an equation, what you do to one side, you have to do to the other. Hence, we're going to have x equals minus 12 over 4, which is minus 3, which becomes this. Good. Okay, so that's what we get. So again, we get two solutions here, right? We have negative 3 halves, and we have negative 3. What questions do you have about this? Yeah?
So for the answer, do you write it in a solution set with 2 parentheses, like -3 comma -3/2, and then parentheses?
Not like that, though, because if you write it, you mean like, let me see, where is it? Do you mean like something like this?
Yes.
No, you actually don't do that because this is an interval. You include everything between the numbers, and we don't want to do that.
So you would just list it as x equals -3 and x equals -3/2?
Exactly.
And then you wouldn't put it on the, like if you were to draw it on the number line, you wouldn't put like an open circle over -3?
No, you don't graph it. No, no. I mean, I guess
Oh,
I'm
okay.
thinking, I want to say some books, some people might sketch it on the number line as just putting two, circles or whatever on the number line, but you don't have to sketch that. No, you only have to sketch intervals. Okay, good
Okay,
question.
thank you.
You're welcome. Thank you. Good question. Right, so again, yeah, I mean, you don't want, the way you would actually list this, you could just list the numbers. So that's all you have to do. Okay, I mean, I want to say Lumen might have you write it in between curly braces. I don't remember off the top of my head, to be honest, but you definitely don't have to, you definitely do not write it like this or this, because there's only two solutions there. Okay, awesome question. Any other questions? Okay. Okay, so let's do another one then. Well, actually, let's do an inequality. Okay, so let's solve this inequality. Now remember, what does this do? This gives us this corresponding compound inequality. Namely from here, where is it? Right here, right? How do you solve this kind of inequality? You solve this. You have this compound inequality to solve. So from this inequality, we get 2 to solve. So from this inequality, we get these 2 to solve. That's what I'm trying to say. So we have to solve this. Okay, that's not so bad. Remember, the way to solve this kind of inequality, you have to get x all alone in the middle. That's what you want to do. So in this case, the -2, we have to get that out of there somehow. Now, how do we do that? Well, it's not that bad. You just add 2 to everything, right? We have x -2, but we want 2 there, so we add 2 to everything. Okay, so let's do that. We add 2 to each side, right? We add 2 to get it out of there, but again, you have to add 2 to everything to keep everything the same algebraically. What you do to one side, you do to the other, basically. And that's what I'm doing. So we get x greater than or equal to 1, less than or equal to 3. And so from there, what we actually have is this compound inequality. And here we're actually done. Okay? Here, we are actually done. right? So since we have this, this tells us, since we have x all alone, our solution set looks like this. Okay, that's our solution set. Is this interval? And if you were to sketch it, you would have 1 under here. It's over to the left a bit, but that's okay. To 3, you have these closed circles, right? And then you would sketch the line between to indicate that you include everything between 1 and 3. Not sure why the 1 is shifted to over to the left a bit, but I'm pretty sure everyone understands that 1 is under this. Okay? You know what? Just to make it easier, let me do this. There we go. Okay. Good. Good. All right. So again, that's another example. Let's do another one actually. Here's the same idea, right? What do you do from this inequality? You get these 2 inequalities to solve. From here, you get a compound inequality. So we get -5 less than or equal to -2x plus 3 less than or equal to 5. Right, again, it's just like what I did over here, right? From this inequality, you form a compound inequality. Same thing here. So what do? We want x to be all alone in the middle. Well, we have -2x plus 3. Okay, well, let's get the 3 out of there first by subtracting. And what you do to one, you have to do to the other sides, right? Just like in an equation.